This is a starter that failed. In today's video, I'm going to be taking this apart, showing you how it works, showing you all the parts inside, and even explaining how it failed. You're watching Car Simplified. This whole thing is considered the starter. This is the starter motor, this is the starter solenoid, and this is the starter gear. When working properly, this starter gear is only in contact with the flywheel when it needs to be, otherwise it's pulled back. There are some internal parts in here that make that possible, and I'll show you that later in the video. I'll start by taking the solenoid off the rest of the starter. So there's our solenoid. It's not much to see because it's an electromagnetic item. This chunk of metal here is pulled on by the electromagnet, and when it comes out, it pushes this gear out to mesh with the flywheel. You may also notice that when it comes out, it rotates a little. That's important because that movement, along with the beveled edge of this gear, helps it mesh with the flywheel as it moves forward. You can't always count on the flywheel to stop in the same place every time. This spring is in there to help this return into place when it's not in use. That brass piece inside the solenoid is actually a switch. That switch electrically connects these two posts here, and that means electricity is sent to the starter motor. Let's take a look inside. So before I take this casing off, I just want to point out this wire here. This is a positive wire, and it's insulated from the case because the whole case is the negative or ground. Whew. So this is the brush assembly, or at least what's left of it. Continuing to follow power, it heads through this wire into these brushes. These brushes make contact with the armature, which is one of the next things I'll show you, but these stay still and the armature inside of them rotates, and these pass electric current through the particular parts of the armature that they're making contact with. Now these brush components wear out over time, and that's exactly what happened here. They're not supposed to be in little pieces like this. They're supposed to be a solid chunk of metal. 4 total on this particular model. In the past, it was actually fairly common to replace just these brushes or even replace this whole brush assembly. You can still sometimes do that, but you'd have to find the source of these little parts, and they're difficult to find now. I'll show you in a minute why, even if this was available, it wouldn't have been able to fix this starter. So this is the armature. This is the core of the starter motor. This is where the brushes make contact, and you can see this is pretty rough, but that's not even the worst of it. See this chunk right here? That's really not supposed to be like that. I don't know what kind of shape those brushes were in before this happened, but after this happened, those brushes didn't stand a chance. This armature would be spinning really fast, and that lump right there would tear those brushes up with one start attempt. As I rotate this, you may notice on the core here that there's these little notches cut out of it, and they're on one side on one part and on the other side over here. This is a dynamically balanced motor. As it spins, if the weight was off, it would cause a vibration, and you could just grind right down in the middle. That would give it a static balance, but that could still cause a little bit of a wobble. So dynamic balance like this is the way to go. Either side of this armature rides on a bearing. This side's just a solid metal bearing. This particular starter had a service port on the back so you could check for play in the armature. So with this being the back end of the armature where the brushes are, this side has a gear on it which goes into the planetary gear set. This is a sun gear. There's planetary gears that go around it, and a ring gear that would be stationary attached to the case. That's where that gear on the armature attaches. There are 3 planetary gears that will rotate around that sun gear on the armature. Also inside there are 6 curved permanent magnets. And as the brushes make contact with these copper contacts here, they send electricity through particular areas of this armature that create a magnetic field that pushes and pulls on those magnets on the inside, and that's how you get your rotational motion. The magnets are attached to the inside of this case, and that's pretty much all this case holds. This aluminum piece has a roller bearing on the inside. This particular bearing is a little dried out and not happy, but it's the least of this starter's problems right now. So this is the full piece of metal that drive gear is made out of. This sits inside that roller bearing I just showed you. So here's that piece of the solenoid that gets pulled in and out. Normally this sits right here. This fork pivots on this piece of plastic right here. The fork itself is actually made out of plastic too. So there's the pivot action. This fork sits in this groove right here, and when the solenoid activates, it pushes that gear out. As it comes out, you can see those coarse threads that it rides on that forces it to turn as it comes out. Before I show you the gears, I'll show you this gear reduction in action. This is held in place, so you can see as I turn the armature, I have to turn it a whole lot to get that outside gear here to turn even a little bit. This gear reduction is a trade-off. Although you're losing speed over here, the torque that you're generating with this armature is multiplied as it passes through these gears. Let's take a look at that gear reduction. As I mentioned before, this is a planetary gear set. The sun gear at the center of the solar system is on this armature. The planetary gears, there's 3 of them here. They rotate around the sun. And then finally you have your ring gear here, like an asteroid belt. I guess they gave up on the naming convention as soon as they got that far. Notice that these planetary gears are all attached to these pins, and those pins go down to the carrier below them. The speed of the carrier here is the same speed as this output gear here. Planetary gear sets like this one are also commonly found in automatic transmissions. Not all starters have this gear set though. You may remember me calling this a gear reduction starter. If the armature spun at the same speed as this pinion gear here, that would be called a direct drive starter. Another important thing to point out about this part is meshing. If the rotation you get from this extending and these beveled edges aren't enough, and it stops before it gets out all the way, this spring right in here, there you can see the spring. That spring actually allows the forks to continue moving like this. So that way the solenoid can move all the way, the motor will get power and it'll start turning, and as soon as the teeth line up on the flywheel, this can move back out and it engages. This also has a one-way or overrunning clutch in it. So you're starting the car and the motor's turning this way, but all of a sudden the engine starts up, your key is still turned on and your starter motor is still going. This hasn't drawn back in yet, but your flywheel is suddenly moving faster than the starter wants to go. Well, there's a one-way clutch that allows this to turn that direction. That way you don't overspin the starter and wear out those bearings. So that is everything that's inside a gear reduction starter, an explanation of how this particular one failed, and an explanation of how both types of starters work. If you enjoyed this video, check out my auto parts disassembled playlist. I've got a bunch of other videos like this one, and consider subscribing. Thanks for watching, and I'll see you in the next Cars Simplified video.